Ever wondered why electric cars have that distinct rear end design? Even SUVs have that sloping C-pillar, and car makers advertise them as coupe or sportback. So actually pulled out some data, and apparently nearly half the newest performance SUVs and majority of electric cars have that rear end design. But cars weren't always designed this way. In fact, most of the SUVs in the last few years look like this. Notice how the tailgate and the windscreen are in the upright position contrary to what we have seen earlier. So what exactly caused these changes? The teardrop shape, also known as streamlined or aerodynamic shape, is inspired by the natural form of a raindrop. This shape is characterized by a rounded front and a gradual tapering rear. When applied to cars, it leads to several aerodynamic advantages that contribute to fuel economy improvement. Because electric cars rely on battery power, minimizing energy consumption is vital for extending their range. When an electric car has an aerodynamically efficient shape like a teardrop, it requires less energy to overcome air resistance at higher speeds. This energy efficiency directly translates into longer driving range for electric cars, as well as less power consumed to drive a certain distance. Similarly, less fuel is consumed for petrol-powered cars due to this shape. The teardrop shape helps minimize the drag coefficient of a vehicle, which is a measure of how aerodynamic an object is. By optimizing the shape to reduce turbulence and air resistance, the drag coefficient can be reduced significantly. The lower drag coefficients results in lesser energy required to overcome air resistance, thus enhancing fuel efficiency. Aerodynamics was first used to increase vehicle performance in race cars during the 1970s. Race car engineers realized that air flowing around the vehicle could be used to increase downforce and reduce aerodynamic drag on the car. As fuel economy became a strong factor in road vehicle design, engineers soon realized that methods of reducing aerodynamic drag on race cars could be transferred to road vehicles to improve fuel economy. To decrease the amount of drag created by a vehicle, automobile manufacturers began incorporating body vehicle designs that would allow the vehicle to be more streamlined. Methods of decreasing the drag coefficients of a vehicle included reshaping the rear end, covering the underside of the vehicles, and reducing the amount of protrusions on the surface of the car. The streamlined front of a teardrop-shaped car allows air to smoothly flow over the surface. As air moves over the car, it sticks to the shape rather than creating turbulent zones, reducing the separation of air from the vehicle surface. This improved flow attachment further reduces the drag, making it easier for vehicles to move across the air with less effort. The combination of a reduced drag coefficient, improved flow attachment, and minimized wake regions all contributed to fuel economy improvements. Vehicle designs with a rear teardrop shape required less energy to maintain a given speed, resulting in better fuel economy. While the rear teardrop shape offers substantial benefits in terms of fuel economy and aerodynamics, there are considerable challenges and limitations to consider. Firstly, practicality. Achieving a perfect teardrop shape for everybody's passenger cars can be challenging due to factors like passenger and cargo space, safety requirements, and aesthetic considerations. Designing vehicles that can balance all these factors with aerodynamics is a complex task. Secondly, cost. Incorporating advanced aerodynamic features can increase production costs, which may be passed on to consumers. Striking a balance between cost effectiveness and fuel efficiency is a key challenge for automakers. Lastly, improving aerodynamics may lead to trade-offs in other areas such as interior space or vehicle handling. Engineers must carefully balance these factors to create a well-rounded vehicle.